Good morning, gentlemen. Your mission today, should you choose to accept it, is to bid making all of the white parts. I'm working with Buckhorn Rubber on making a contraption that would retract the injection head. It's a company in Springfield, so I've had to do a lot of this sort of YouTube communication. The back plate that you're looking at here, 13 inches wide, 3 inches deep when it's all bolted together, so that's really 2.5 inches deep. Everything's made out of 1/2 inch plate except for this extension rod, which I'll get to. But the front plate and the sides would all need to be welded, and I suspect you'll end up having to weld this bend right here, because I doubt that you'll be able to bend the 1/2 inch plate at that angle to form this back here. You'll also be, after it's welded, you'll have to drill and tap and make a bolt pattern on here for threading the rear plate on. I couldn't get the piece to bolt onto the machine unless I made it into a couple of different sections. So you could add another 6 bolt holes onto there. This is just for a bid at this point, so I haven't done any of my AutoCAD drawings with actual dimensions on them and everything. This was just to communicate with the customer and now with you. So you can see some more dimensions here. It's 15 inches tall overall, so that would be one large piece you'd need to make. And then back here I've got a piece that's 4 3/4 inches tall, about 7 inches wide, and 15 inches long. Also would be some welding involved here. You'd have to make a couple of these plates for either side, a top and a bottom plate, and then have them all welded together, and then probably come back and bore the hole for the pin. I was just using probably the same material, although this is quite a bit smaller. This is like a 1.5 inch pin, and this is a 3-inch bar. I didn't draw it correctly, otherwise it would look a lot bigger. Anyway, maybe some S7 tool steel, or we could go with some cold rolled. There's 30 tons of force pulling on this, so the beefier the better, and then just slap a shaft collar on there so it doesn't fall through. The machine really would keep it from falling through anyway, but I still thought the shaft collar was necessary. But I've got the shaft collar in my portion of the bid, which includes the blue parts, the clevis here and the cylinder. So I just need a price from you on the pin here, which wouldn't need too much, just about a 5-inch long pin and a shaft collar divot there, and then I need a price for this fabricated clevis, we'll call it, and this mount at the back. And this bar is going to be 3 inches long. It would have a female thread in there that is 1 inch 12, and I can get that from MSC for $31. If it breaks, I can have you guys fabricate one out of tool steel, but I think that would probably work. The cylinder people are telling me that they guarantee that the 1 inch 12 threads will hold that 30 tons of retract force. On the other end, the clevis has a 65 by 1.5 millimeter thread, so your shaft would have a 65 by 1.5 thread on there, and I would just assume make that part of the shaft so it's easy for you guys, rather than thread it and try to make a stud. Obviously the 1 inch thread on the cylinder is going to be the weakest link. The clevis is much beefier than necessary. You wouldn't have any labor and assembly. That would all be done by the customer, so you would just hand me a box full of parts, and then I'll drive it down there and they can install it. So calculate everything based on 1/2 inch thick material, probably cold roll, so it's nice and flat and there's no scale to worry about, and it's probably stronger that way. I've calculated all my thicknesses based on the thicknesses that are purported to handle this load from the clevis manufacturer and the cylinder people. So 1/2 inch thick at these widths should work. Let me know if there's any other information. You got my number.